Good day viewers, well, you don't need a VFD. Running a 3-phase motor with a hand crank generator. Backwards, goes the other way. Now it's like a wash machine. See? It's a wash machine V-phase motor. Now it's agitating. This little motor here is better because it's a small fraction of horsepower. That goes much faster. That's easier to turn. Easier to run a small motor than a bigger motor. I'll try the pipe motor. See how that does nothing. It's a shame that motor made pop again. It's a nice little, a good brand, a nice little motor. Expensive brand too. I looked on their website. Those motors aren't cheap. Shame because it's got that stuff at Metric, which is a most places around here buy 3-phase motors from Metric website, but they're pretty cheaply made. There we are. Look at that. He needs a VFD. Let's run this by hand. Run 3-phase motors by hand. Anyway, works quite nice. Since that motor's half smegged, I'm going to try and get in contact with a local motor rewinder just to see what some prices are. They get these little 3-phase motors rewound. See how much it's going to cost. Just curious to know. Because these are pretty good brand 3-phase motors. So anyway, that'll be enough for now. Thanks for watching. Good day viewers, I'm going to give you Ubuntu Studio again on another machine. This version is I put it till last month. Oh well. Oh, this the latest version, 64-bit. I got this HP pile of junk. Very HP specific. I mean HP specific as you can get. Running Windows on this thing had nothing but blue screens. Drivers just would not work on this thing. It's too HP specific, so blue screen's too much of Windows. It's all driver related, so bugger it. I decided to just see how it runs Linux. I don't think I ever tried it on this machine. It'd be great for that because Linux knows what it's doing compared to Windows, so I think Linux will run fine on this. I think it's got I think I only got 2 GB of RAM in this. No, they're 1 GB sticks. 3 GB of RAM in that. Pentium D. I moved the CD DVD drive on the next bay down so I can reach the short reach between the hard drive and the CD drive. So fit it nicely. Let's see if this works. It should be great for Linux Ubuntu Studio. It's pretty much a media center PC, so I thought, well, this would be a very good candidate for Ubuntu Media PC. I watched the video and I quite like it. It's quite nice. Got everything pre-installed. So let's get this thing all together. It's a hard drive from a PVR. Pick them up for next to nothing at the recycling centre. So they're a great source of cheap hard drives. You can't really get anything off them because they're encoded. So great source of cheap, good hard drives. The hard drive tested fine too. So let's go on in here. Let's see how we go with this thing. Okay, viewers, well, I took the 900 cold Krakenet battery back. That's dead as a maggot. That went in the scrap pile, and I picked this one here up, same place. Oh yeah, let's see how we try our luck. It looks like it's been sitting dead for a long time, but nope. It's come up quite nicely. It's recharging quite nice. So this battery might be survivable. Let's give it a test on camera. 520 cold cranking amp. This one's really good. This is near new. That'll go with the other one, as I said, in my solar system. 13 milliohms. It was 99 milliohms when I started. 13.9 volt. That's not doing too bad at all. I'll give it a week or two. You gotta have it on for a while. It was on 0, so leave it off for a week on the recovery charger. I might even I'll put this C-Tech on it. Because this one has actually gone down now in ESR, which means it's desulfated, which is good. This now I want to see the same result. If it does and it stays below 5 milliohms on that Delcore battery, that smaller black one, and it stays at 5 below milliohms on the ESR, that means that battery is all desulfated. And it will hold its charge, so that's a good thing. I went to charge this vacuum cleaner and there you go. So going, no, I can't charge it. I've took this apart, checked the fuse on it, and it's blown. Changed the fuse on the primary side, bang, it blew again. So the power, this wall wart's gone short somewhere. There's a short in that wall wart. There you go, the fuse is blown. It's a 1 amp fuse, blown the smithereens internally. So I've all is not lost because I've got this raw dang power supply set up now. So all is not lost. It just makes it more inconvenient now because now I can't really run this thing off my solar system. Although it's not doing much like that anyway. Maybe it can run off the inverter. I think it can. Well, it's not pulling bugger all current, so I think I can run it off that. Not wise too though, because this thing, what's this thing pull? 0.5 amp from the mains that pulls. I'll do an analysis on this transformer. I'm pretty sure that's going to pull a bit more than 0.5 amp doing this. But it conveniently had the markings of the cable, which way positive and negative was. I just hook it up to this, set it to 28 volts as it says on there in the DC output, 28 volts, 400 milliamp. I've got it set at an amp. It's only pulling 350 milliamp. The circuitry in here does everything else. Your charging, your battery monitoring, everything is done in here. So all you need is an ordinary power supply. It puts at 28 volt and at least half an amp is enough. The circuit inside this thing won't pull any more than what this power brick's rated for anyway. So I was hoping to pull maybe, I don't know, because it was flat. It's got up to an amp to use here. I say, oh beauty, this thing's going to charge quick. Nope. The circuitry in there is smart enough to know that. So the BMS and all the charging circuitries in there, it's only going to pull the maximum of 400 milliamps no matter what. So as I said, I got it set to an amp. I'll set it to, hang on, half an amp. There we go. Now it's only going to give me 28 volts at half an amp, and it's been on here for about 2 hours now. There was dead flat the wire fuse that never charged it, and I went to use it after I come home from work, but yeah, flat. So yeah, 2 hours on this charger so far. Takes bloody all night to charge. But I'll have to, I'll keep an eye on my local store, see if I can, I've got a photo of that, I'll leave it on there. I'll do some scrounging around the local recycling centre for wall warts. For fire one, it's 28 volts at that 400 milliamps or more. I'll grab it, and that's going to be soldered onto here. That way, you know, I can have it how it should be. This is just a bit. It's good, but it's too bulky for charging a vacuum cleaner. Now you're pulling a bit more current than you need to charge a vacuum cleaner, although I could run it off that. It's not warm, only idle temperature, still. It's great, this power supply is great for things like this, it's awesome. It's a bloody lifesaver. I'll keep an eye, as I say, I'll keep an eye out. If I can't find one, I'll just buy one off eBay. You can buy these proper replacement ones off eBay anyway for this. So another thing I tried, I brought my motor back. I thought, oh yeah, I might just try the other capacitors. So I took the start capacitor off that motor, put it on here, and it started good. Put my foot in it and kicked my foot off the shaft. Yeah, it's just got plenty of starting torque, so this motor itself is fine. The windings are fine, it's just the capacitor. So I've ordered a new good one off eBay. That's a 195 microfarad start capacitor, and that started this thing nice. The one I ordered was a 200 microfarad. It's a Mallory brand. Well, Mallory is a good brand of capacitor, so I didn't buy a cheap heap of crap. One thing I didn't notice, no overlap protection on that motor, but this one here does. That's something I really want. It's important to have. That's a 1 horsepower, this is a 1.5 horsepower. That's the main difference. So I'm going to grease up those bearings, take this plate off and use it as a template and make another one for that one. So I'll make up a new one of these plates to go on the back of that motor. So this motor's fine, which is good. I'm going to clean it up, mask off the label and give it a new paint job. This is a compressor duty motor too, so that one there is just an ordinary 2800 RPM all rounder motor, continuous rated, same as this one, but this is specifically compressor duty. It doesn't say though what the capacitor should be on these labels. Some motors do and some don't. 7.8 amps at full load. Crompton Parkers in Australia, a good company. As I said, Crompton Greaves, India, still make their motors. So 1.5 horsepower, 2850 RPM. As I said, I'm going to give it a clean up once the capacitor arrives and this thing runs good. Grease the bearings because they're a bit noisy in this. I'll just work on this shaft because it's slightly bent, but I can make up a jig. So this is the far end, I hit it on there and just straighten it out carefully. I could put it on a lathe, but then I'm going to have to use a shim to put a new pulley on it. It's 99% straight, there's a slight wobble on it. But I'll make up some sort of a jig to fix that. Put a stress relief on there, strain relief, and just clean up everything in there. Those wirings are pretty dirty, so I want to clean those up and just get all the debris off it. Make this thing really clean inside. So potentially have 2 good air compressor motors now. Awesome. I don't know how a 1 horsepower motor is going to go though. It's a 1 horsepower motor, and I think it should be right. I think the motor on this compressor here, this other one here, is 1 horsepower. What is it? 4.78 amp, 0.75 kilowatt. That's 1 horsepower, and that goes fine. So I could use that little smaller motor on here anyway. 1 horsepower is doing fine on this, plenty. So now I've got although I probably will leave that motor on there because it's not too bad anyway. It doesn't take too long to charge the tank up anyway. And this compressor is not rated for much RPM, 1300 RPM max. It won't hurt it to go faster, though it has been driven faster than that most of its life. 1400 RPM, yeah. 1400 RPM on that. So you work out what that's going to be. I've got to work out the ratio, how fast that pulls. What I could do is just put a tacho on the pulley and measure the RPM of the compressor itself. Not a big issue, but if I want to be a high demand air compressor, if I ever need it to be a high demand work and want to top up the tank faster, I've got that option now. 2 motors to choose from to fill the tank up quick. Or I could give one of these to my dad, because his air compressors that are, I've had it in videos before, little CMG 1400 RPM motor. I could put one of these motors on that compressor and just put the original smaller pulley on it, and that'll be fast for him as well. I have a fast motor, he's got a fast motor, so but yeah, it's good to have an option now. Sweet. I was hoping that motor wasn't the windings wasn't the problem. Awesome. I'm happy about that. Anyway, that'll be enough for now. Thanks for watching. The next video will be about the rest of that PC with Linux Ubuntu on it, so I'll set it for the next video. Thanks for watching.